Today's Algebra 2 2.7 Parent Functions and Transformations. You will need a graphing calculator with you, as long with your pencil and your calculator, and maybe some graph paper. If you need that, I can get that for you. It'll be on the table up at the front of the classroom. So the first function we're going to talk about is a constant function. A constant function is where f of x equals a number. So if you look at here, f of x equals a. And a can be any number. In this case, a was 1. The domain is all real numbers on this. So it says domain is all real numbers. And the range consists of a single number. So if you're looking at this graph here, this line goes on forever. So all of your x values are covered. All of your x values could go in here. But you're only going to get one y value back. When you plug in any x value, you're going to get only one y value back. So your domain, how you would write it, is because it's all real numbers, is negative infinity to positive infinity. Your range for this particular one is just going to be 1. It's included in the graph. There's no other numbers in it, so it's just 1. If you're looking at a constant function, they also have a slope of 0. If you remember that slope to video, this is a flat line here, horizontal line. It has a slope of 0. The other one we're going to talk about is the identity function. The identity function is always y equals x, or if you're doing it as a function, f of x equals x. It passes all points with coordinates a. So what that means is 1, 1, 2, 2, 3, 3, 4, 4. Negative 1, negative 1, negative 2, negative 2, negative 3, negative 3, negative 4, negative 4. All of those points will be on that line. The slope of this line is, this in particular one is 1, because you go up 1 over 1, up 1 over 1, up 1 over 1. The identity function is always going to be a slope of 1. Now, you can change this by doing a different slope. It's not necessarily it's not the identity function. The identity function is the f of x equals x1. The domain for this one and range are the same, and it's all real numbers. So you would write your domain as negative infinity to positive infinity. Your range is also negative infinity, positive infinity. Absolute value functions, we've already talked about how to graph these, but we want to talk more about how we move the transformation of them, how we move them, and their domain and range. So we've already talked about what the graph looks like. It's always going to form a V. F of x equals the absolute value x is the parent function of it. The domain is a set of real numbers. Negative infinity, positive infinity. The range for this particular one, remember, you have to look at what is the first y value you come to. This one's 0, and it goes to positive infinity. The next one we're going to talk about is the quadratic function. I know on one of your homework assignments you had to graph a quadratic, and so you made a t-chart, and that's fine for now because you don't know anything else of how to graph these yet. And we'll graph these later. Unit 2, I think, we'll graph quadratic functions, and we'll learn all of the characteristics of them. Right now, what I want you to know is that a quadratic function makes a u, okay, versus the v that the absolute value function makes. The parent function is f of x equals x squared. The domain for a quadratic is negative infinity to positive infinity. Your range works like the absolute value. This graph's never going to go down here, so the very first one it touches is 0, y value-wise, and it goes to positive infinity. And so for this graph, let's get your graphing calculator out and use that. If you hit y equal, push the clear button so it clears out your whole menu. Then you're going to hit the variable button, which is underneath mode. It should put an x in there. And then hit x squared. So you have x, and then you hit the square button. It's the fifth button down in the first column. Then you're going to hit graph. Graph is at the top right. It should automatically graph the quadratic function that you see on the screen here. Now the cool part about your calculator, well there's many cool parts about your calculator, but the first cool part that we're going to talk about is if you hit the second button and graph, it gives you your t-chart. It makes the table for you. So you can verify your answers right now by putting in the function that you want to graph and then hitting second table and then making your points like that way. So that's one of the ways you can do that. Let's get into some more parent functions here. Maybe if I can get this to cooperate. There we go. So it says identify the type of function represented by the graph. So hopefully you can answer this one. This would be a absolute value graph. B, identify the type of function represented by the graph. Quadratic. It's in the shape, it's a parabola, it's a quadratic function. I'm going to give you a second to answer this question and then I will hit the button and answer it. Identify the type of function represented by the graph. Constant function. It has a slope of 0. Identify the type of function represented by the graph. The identity function. Okay, so I want to talk about translations here for a second. We're going to skip to a couple other slides and then we'll come back to that one. And we've talked about this in Algebra 1. It's talked about, we'll talk about it in Algebra 2. I know they do it in Pre-Calc Trig. Lots of your classes will talk about this. The translations. If you add to the parent function and it's inside the parentheses, it moves however much you have added to the left. This one's a little bit tricky. Okay, it adds it to the left. If you subtract an h inside the parenthesis, h moves to the right. That your graph moves to the right that many units. And I will have this screen printed out and the screen that tells what type of function it is at the table in the front of the classroom, so you can grab those when you're ready for these notes. If you're adding a number outside of the parentheses of the function, it goes up. And that's normally how you would think about it. If you're adding, your graph would move up. If you subtract, it moves it down that many units. If you put a negative in front of the entire function, you reflect the graph in the x-axis. If you evaluate the function at a negative x, it reflects the graph on the y-axis. If you multiply a number that's greater than 1, it stretches your graph vertically. It makes it steeper and it kind of makes it a little skinnier. It stretches it up. If you multiply it by a fraction, so it's greater than 0 but less than 1, it compresses it vertically. It makes it shorter a little bit. It makes it, we say, a little bit wider. So it's pushing down on it. The first one, you stretch it, so you pull it up so it's a little bit skinnier. The compressed one, you push it down and it compresses it and pushes it out a little wider. And those are the ones I want to talk about right now. So now that we see this problem, describe the translation in y equals x plus 1 squared, then graph the function. Well, I want you to see it on your graphing calculator first. So go in your graphing calculator, and in y1, just put x squared. Put your parent function so you can see what's happening from the x squared to the x plus 1 squared. Then go down in your graphing calculator and put the x plus 1, and make sure the squared's outside your parentheses, and then hit graph. You can compare the two graphs by looking at them on the calculator. If you have one of the new calculators, you can see this in color. You can see what happened with the parent function to the regular function. And so if you notice in the graph here, this is what you see on your graphing calculator. The blue one's your parent function, the green one's what happened to it. The plus 1 inside the parentheses made it move left 1. And this one, it says Describe the translation in y equals x minus 4, then graph the function. So you have this x minus 4 here, and so that's what's made it change right there. And so let's go ahead and just graph in our calculator so we can see it. Hit your y equals button, clear the two functions, and remember to get absolute value, you hit second 0, and it's that first one that comes up, that ABS. And so you're going to just put x and then close your parentheses for the first one. Go down to y2, do the same thing, and do x minus 4. And then hit graph. The first function is your parent function. The second function they did moved it right 4 units. So remember that the minus 4 inside the parentheses, or the absolute value in this case, moves it right 4 units. And so you can see the graph that we see on our graphing calculator. You also see that the answer is translation of the graph, y equals x, absolute value of x, right 4 units. This means it took the parent function and moved it right 4 units. Describe the reflection in y equals negative absolute value of x, then graph the function. Well, let's type in our graphing calculator so we can see it. So it's absolute value of x and y1, leave it the same. Go to y2 and clear it. Put in the negative sign, then put your absolute value of x. Go ahead and graph that. You'll notice that what happens is that the function flips over the y-axis there. Describe the reflection in y equals negative x squared, then graph the function. So again, type this one in. Clear both y1 and y2. Type in x squared in y1 and negative x squared in y2. Hit graph. And it reflected over the y-axis there. Oh, I'm sorry. It reflected over the x-axis. Might help if I know my axes. Okay, this one describes the dilation on 1/2 absolute value of x, then graph the function. So if you hit y equals and type in your fraction, absolute value of x, and then well, first of all, make sure you have your parent function in there, and then the absolute value of x. You see that one, that fraction, it compressed it. It made it go out a little bit wider. So you can see it's wider than the original one. The original one went through negative 1, 1, negative 2, 2, and then this one 1, 1, 2, 2, 3, 3. So you can tell it's wider there. Now if we multiply by the whole number, so now we change it to the absolute value of 2x, you're going to see in your calculator that this one stretched it. It made it taller, made it a little bit skinnier, and compared to the original one. So you can tell it goes on the inside of that negative 1, 1, negative 2, 2. So let's talk about what happens on this one. That's really what I want to talk about. Pause the video and see if you can figure out everything they did to it. So hopefully you figured out that the negative sign, well, first of all, we're dealing with a quadratic because it's squared. The negative sign flipped it. The 1/2 compressed it. The negative 5 moved it right 5. And the plus 12.5 moved it up 12.5 units. So here's our original graph in blue. It flipped the graph, so it was pointing down. The negative did. We moved it 5 units to the right and up 12.5, and it's compressed. Let's do one more. Remember, the negative flips it or reflects it. The 1/4 compresses it. The plus 4 moves it left 4, and the minus 2 would move it down 2. And so they only were talking about one thing here. The plus 4 moves it. This is wrong. This should say the plus 4 moves it left 4 units. You can tell by their graph. Their graph moved it left 4. They just have the wrong wording here. And this includes 2.7 parent functions and transformations.